am in the Royal Northern College of Music, where we're using one of their theatres to host a mass inspiration show. So as well as me, I'm joined by my mathematical friends Hugh Hunt, Rob Easterway and Katie Steckles. And in a moment, we're going to have hundreds of teenagers in here to be excited about mathematics. I thought, while we're a bit bored backstage, because there's only one of us out here at a time, I would challenge the other speakers to show me the best bit of mathematics they can fit on a postcard. Turns out backstage at a College of Music, you get a piano in the dressing room, but that's more than enough of that. The show has started and seems to be under control. Katie is not on yet. She's also backstage somewhere, so I'm going to go find her and extract a postcard worth of maths. I'm backstage now with Katie Steckles, who you may remember from other videos on the internet, and you've just shown the young people a whole lot of maths puzzles. I'm going to give you my one standard issue postcard for you to do a puzzle, or your favourite puzzle, I believe, or some interesting maths. It's up to you. Okay, so I have a puzzle which is to do with drawing. It's a drawing puzzle. Okay, so I'm going to draw a shape on here. I'm going to do it using lots of separate lines. Oh, okay. So I'm going to do it in separate sections like this. But in fact, the puzzle, the challenge, I'm drawing a house. The challenge is to try and draw this house without taking your pen off the paper. So you've got to put your pen down, draw the whole thing and take your pen off and not go over any line twice. Do I have to finish where I started? No. No. Okay, shall I try it? Yeah, have a go. Oh, shall I do it with the green? I'll do green and go over the top. Okay, here we go, ready. So I've got to start somewhere. So I have a sneaking suspicion if I start here, it's not, can I go back, so can I do a lap like that and go back to there? Yeah, you can do that, yeah. And then back out of that node and then down here, and now I can't do it. So, because I'm either going to end up there or there, right? So yeah. I'm going to make, right, you know what, I'm just going to do it over here from scratch, right? So there's that. Yeah. And then there, oh my goodness. Oh. Is that it? Excellent, yes, yeah. I don't know how I did that. That was completely by accident. Okay, well, I know exactly how you did that. Because this is quite a mathsy thing. So, in fact, if you're ever faced with this kind of challenge, can you draw a shape without taking your pen off the paper? There is one simple check you can do to see if it's possible. Right. Okay, so if you've got the shape here, so we'll use this one that you've drawn. My success. All you need to do is, first of all, count how many lines go in and out of each point. So we've got a point up here, that's got 2. We've got some points here that've got 1, 2, 3, 4. Going in there, yeah. We've got 4 going in there because it's symmetrical. Yeah. We've got 4 going into the middle, and these 2 bottom ones are 3. And what you'll notice about those numbers is that there are only 2 odd numbers. Right. Okay, so that is the thing you're looking for. If you've got more than 2 odd numbers or less than 2 odd numbers, it's not going to work. And if you have exactly 2 odd numbers, you start from one and you finish at the other. Because I must have started... You started in the bottom left corner, yeah. Because when I did this first one, I started in a 4. Yep. I did that lap, and I knew now I was screwed, right? Because I have to get back into here to finish that line, but I've still got to get back into this one to... Yeah. So when you've got an odd number, you can go in and come out, but you're always going to have 1 spare. So even if you've got 5, you can go in and come out twice, but you've still got 1 spare. So you're going to need to use that as your start, and you're going to need to use one of those 3 as your finish. So if it's got an odd number, it needs to have a line with no other line going anywhere. So you either come out of it or you end in it. Yeah, exactly. Does that work for any network like this that only has 2 odd nodes? Yes. Anything that's got only 2, you should be able to do it if you start at one of the odd nodes and finish at the other one. If it's got no odd nodes, if it's all even, you can start anywhere and finish anywhere. But you can definitely do it. You can definitely do it starting from anywhere. And if it's got more than 2 odd or less than 2, if it's got 1 odd, you can never do it. Can't do it. Yeah. That's it's a life hack. So you could draw any random series of lines and just make sure there's 2 or fewer odd. No, just exactly 2. Because if you've got 1, you can't start there and finish somewhere else because all your other ones you need to go in and out as well. So, right, I'm going to try that. That is so good. So if you want to get this to go, get a bit of paper, draw a network. Because Euler did some stuff on this, if I remember correctly, because there's bridges of some place in Europe. Yeah, if you've got all evens, it's called an Eulerian graph. Right. And if it's got just the 2 odds, it's called semi-Eulerian. Semi-Eulerian. Yeah. That's the best sentence I've heard today. So you go and get your own semi-Eulerian graph and then see if you can draw a line around it. Because, yeah, I've heard about this stuff before, but I didn't realize it was such a strict condition. And it guaranteed it. Yeah. That's brilliant. So there's some good maths on a postcard. So that is one postcard's worth of mathematics. If you want to see the other 2 postcards worth of maths, you can check out the other 2 videos in the series. And if you are a teacher, we do these maths inspiration shows all around the UK. They're great fun. We have different speakers every time, and we thoroughly enjoy exciting your students with mathematics, and so they go back to the classroom hopefully more eager to learn. You can check out more information on it at mathsinspiration.com. It'll be great to see you at one of these.